Welcome to another video. Let's solve another Olympiad algebra problem. But if you pay attention to it, you notice that this is exactly this. The x and the y are just switched. So looking at this problem, you might start thinking, maybe I can do some substitution. No substitution. It gets too complicated. Elimination. Because by elimination, we can get to our answer faster. Another question you have to ask yourself is, how many answers am I supposed to get? In a problem like this, you don't know. Until you start, you can't tell how many solutions you're going to get. So let's start by distributing because there's nothing we can subtract straight away. So let's just do distribution. If we look at the first one, we have xy squared plus 6x. And then we multiply this, it's going to be minus y squared minus 6. Here we're going to have x squared y plus y. Okay, so we have the first part taken care of. Let's do the second one. We're going to have y times x squared will be x squared y. I want to put the terms that are together on the same side. So y times x squared will be x squared y. It's supposed to be on this side. But just to save space and time, instead of writing x squared y here, I'm going to move it here, but it's going to be negative. Okay, next one. Y times 6 is going to be 6y. Where do I have y here? Here. So instead of writing, because it's on the left, instead of writing plus 6y, I'm going to write minus 6y here, just to make things faster. Then here, minus 1 times x squared is minus x squared. Well, this is the only squared that I have, so I can write minus x squared here. Okay, minus 1 times this is going to give me minus 6. I can write minus 6 here, that's fine. I go here, x times y squared is xy squared. I want to write it here, but it's going to be negative since I'm bringing it here, negative xy squared. And then x times 1 is going to be x. Put x here. It was positive here. On this side, it would be minus x. Okay, so I have two equations. Let me label them equation 1, equation 2. So generally, when you're doing elimination, you subtract and then you add whichever one helps you. Now, I do not know which one is going to help me, but usually when I do elimination, I just subtract. Oh, it looks like adding might be easier. Okay, but I want to do subtraction first because I know it's going to lead me to some of the answers faster. And then we come back to do addition. So let's do subtraction. So let's subtract the bottom one from the top one and let's see what we get. If I subtract this from this, that doesn't help. Actually, it looks like it gets more complicated. So let's still do it. So if you subtract this from this, this will not go away. You're going to end up with 2xy squared. Subtract this from this, you're going to get 7x. Subtract this from this, this is going to become minus y squared plus x squared. Remember, you're subtracting this from this, so it's this minus x squared, so it's going to become plus x squared minus y squared. Subtract this from this, you get 0, so that's gone. Subtract this from this, you're going to get 2x squared y. Subtract this from this, you're going to get plus 7y. Okay, do we have anything that cancels out? No, nothing cancels out. So that means we have to try to do some factoring because I don't see anything canceling out. So let's put things together. You know what? I'm going to put this here. Let's say we have 2xy squared minus 2x squared y plus x squared minus y squared plus 7x. If we move this here, minus 7y equals 0. Now, based on the x-y interaction I've seen, I know that I can get x minus y. There's a lot of it. There's x minus y here. There's x minus y here. There is x minus y here. Somewhere it's hidden. So let's do as much factoring as we can. If I factor what's common to this and this, 2xy. So if I factor 2xy, I'll be left with, here I have y minus x plus, oh, this is difference of two squares. So this will be x minus y times x plus y. Okay, and here I can take out 7, and what I have left is x minus y equals 0. So every term now has, this is x minus y, but you can write it as negative y minus x. So I can rewrite this. Let me rewrite it so it makes it easy. I'm going to pull out a negative and then change this to x minus y. Let's do it. So this is x minus y. So now we can take out x minus y from each of the terms. So here we're going to have x minus y. Now what is left? If you take out x minus y, you have negative 2xy left here, negative 2xy. If you take out x minus y from here, you have x plus y remaining, and that's going to be plus x plus y. If you take out x minus y, you have plus 7. Equals 0. So look, we found a key. This is equal to 0, or this is equal to 0. So we can clearly say that x minus y is equal to 0 implies x is equal to y. That is one source of answers, okay? This is another source. We're going to come back to this, but let's deal with this situation where we have x minus y equals 0, which implies x is equal to y. We can go back to the original equation and try to put x where y is and see if we get an answer. To make things faster, I am going to use equation 1 rather than use the original one. X for y. So we have x times x squared plus 6x minus, this is going to be x squared minus 6 will be equal to x squared times x plus x. Okay, so that's what we have. This is now x cubed plus 6x minus x squared minus 6 equals x cubed plus x. Clearly, there's x cubed here, there's x cubed here. If you subtract x cubed from both sides, these two will go away. What do you have left? You're going to end up with, and then if you move this x over here, you're going to have 5x minus x squared minus 6 equals 0. This is actually a nice quadratic equation where we can say if we move everything here, or you multiply by negative 1, we can rearrange this to become x squared minus 5x plus 6 equals 0. Yeah, this is a common quadratic. This can be factored to give you x minus 2 times x minus 3 equals 0, which implies x equals 2 or x equals 3. So remember that the claim was x is equal to y. So the solution that we get from this option is when x is equal to 2, y also is equal to 2, or when x equals 3, y will be equal to 3. So the first set of solutions we have are, so x, y equals 2, 2, or 3, 3. So these two are solutions. Remember, I know that these are not the only solutions because we've only used this part. We have not even touched this part. There is still another set of pairs of numbers that will satisfy this, which we haven't discovered. Okay, let's go find them. I have set this one aside. We're going to come back to it. So let's go back to the first equations that we got. Remember the first time we did subtraction. Let's do addition now and see where we go. It looks like addition is going to lead us to a path that we want to go. So if we do addition, clearly this will take this out. both of these will be gone if we add. So I'm just going to say add. Okay? If I add these two together, see what I'm going to get. This plus this will become 0. This plus this will become 5x. This plus this is going to give me minus x squared minus y squared. Okay, let's just write minus x squared minus y squared. If I add this to this, I'm going to get minus 12. If I add this to this goes to 0. Okay? If I add this to this, I'm going to get minus 5y. So, that's what addition gives me. If we rearrange what I just obtained here, it looks like if I move this guy back here, it's going to be positive just like this one. But then I multiply by negative, I'm going to end up with, or if I move everything to the side, let's just do it and leave a 0 on one side, I'm going to end up with x squared plus y squared. I'm going to have minus 5y. We can actually rearrange this. And because this is a square, so the problem with you having a single equation and multiple terms, and you have squares and you want to try to write them, this looks like the equation of some circle or parabola or hyperbola. You can't tell until you complete the squares. So let's put the x's together. So we have x squared minus 5x plus y squared minus 5y plus 12 equals 0. Can we do completing the squares for this? Yes. Can we do for this? Yes. Now, the beauty of this problem is the same thing you do here that you do here. You just move all the constants to the other side. So let's complete the squares and see what it looks like. I'm going to move this 12 over to this side. So I'm going to have x. If I complete the squares of this, so remember that what you have here, you take half of this. Remember, you need half of this, minus 5 over 2. You square it. That's how you complete the squares. Plus, you take half of this, y minus 5 over 2 also, you square it. Now, you move this over to the other side, it becomes minus 12. Then you're going to add something to it. What would you add from here? Well, it's the square of this term. What is the square of 5 over 2? It's 25 over 4 plus 25 over 4. You do the same thing for this, plus 25 over 4. So now we have x minus 5 over 2 squared plus y minus 5 over 2 squared is equal to, what's the answer to this? If this is hard for you to do, just write this over 4. Okay, multiply this by 4 and divide it by 4. If I multiply 12 by 4, what do I get? Get 48. So I can write it as negative 48, but divided by 4. Now, they all have the same denominator, and I can add negative 48 to 50, that's 2. So it's going to be 2 over 4, and what's 2 over 4? 1/2. Done. Okay, now, this makes our life a lot easier because we can substitute, because this is now a linear expression, we can come back and get what this is. Now here, this looks weird and scary because it doesn't look anyway like this. Can we write this to look like this? I want this to have a leading plus. So I can say this is the same thing as 2xy minus x minus y minus 7 equals 0. So I just multiplied through by negative 1. Now, if I try to factor the way it is now, what is common to this term and this term? What I have is x. But this guy doesn't have a 2, so this is going to be left with a 2y. But I don't want it, so I can take out 2x. So that if I factor the first two terms, I'm going to get y minus, what is left here is going to be 1/2. Okay, because what I have is just, remember when you factor, you're dividing what is here by what you took out. So if you divide this by 2x, you get y. Divide this by 2x, you get 1/2. Okay. In order for this factoring to work, whatever I get in the parentheses here has to be y minus 1/2. but I don't have y minus 1/2 here. What I have is minus 7. Well, since this is a constant, I can do anything I want. So instead of me writing this as y minus 7, I can write it as minus y plus 1/2 minus 7/2. Because now what I have is still 7. But I have provided myself the opportunity to correctly factor this. So see what's going to happen. This is now 2x. Let me rewrite this. 2xy minus x minus y plus 1/2. I move this over, it gives me 7.5. I can write that as 15 over 2. Now I can factor. Okay, so with this, if I take out 2x, what I have is 2x, I have y minus 1/2 minus, well, there's nothing here, it's just going to be y minus 1/2. And what I have left here is 15 over 2. Now I can pull these together, so I have 2x minus 1, y minus 1/2 equals 15 over 2. Why do I really need this? It's because I want it to look like this because I'm about to do something. Now, this still doesn't have the 1/2 that I need, so I can actually factor out 2 here. So I have 2. Remember, when you factor, you're dividing this by what you took out. So 2x divided by 2 is x. 1 divided by 2 is 1/2. Y minus 1/2. And I can actually divide both sides by 2 and move the 2 here, so that what I have here is just 15 divided by 4. At this point, we have survived the toughest part of this battle. And now, it's easy to solve this system of equations. I know this doesn't look exactly like this, but because it's linear, we can actually make something that is common to both of them. So we can say, let's work with this one. Let's say let a be equal to x minus 5 over 2. Okay, and let b be equal to y minus 5 over 2. So that means what we have here can be written as a squared plus b squared equals 1/2. That's easy to deal with, right? So after we get a and b, we just come back and find what x and y are, right? Okay, we want to try and write this also in terms of a and b. So what we're going to do here is isolate x and isolate y. So if a equals x minus 5/2, we can say that then a plus 5/2 is equal to x. So if we go here and we try to write this expression, so this means that x minus 1/2 can be written as, remember this is now representing x, can be written as a plus 5/2 minus 1/2. Well, 5/2 minus 1/2 is 4/2. 4/2 is 2. So this is a plus 2. So we can actually go back here and say that the second equation is a plus 2 multiplied by, if you do the same thing for b, because they're the same thing, we just switched a and b, it's going to be b plus 2. Okay, this is the same thing as a plus 4 over 2, which is a plus 2. Okay, and our answer on the right is going to be 15 over 4. Okay, now it's looking a lot easier. We can actually rewrite this expression here. If we multiply this out, see what it's going to give us. We're going to end up with ab plus 2a plus 2b plus 4. So ab plus 2 times a plus b, if you factor out the 2, and then you can move the 4 over here. You have 15 over 4 minus 4. Well, 4 is the same thing as 16 over 4. So 15 minus 16 will be negative 1. So ultimately, what we have here is just AB plus 2 times A plus B is negative 1 over 4. So now I have to label this as equation 3 because I need it. And I have to rewrite this expression also. I think I'm going to do it on top there. You see, I can't work with the squares. I need AB and A plus B. So how can I write this? Well, A squared plus B squared is the same thing as A plus B squared minus 2AB. Yeah, because A plus B squared is A squared plus B squared plus 2AB, but you don't want the 2AB, so you have to subtract it back. That's how you get this back. Now, and that's equal to 1/2. So see, we have 2AB and A plus B squared. Okay, so we're going to write it that way. So we have A plus B squared minus 2AB is still 1/2. We didn't change the right-hand side. This is equation 4. This is what we can then work with and find something nice. Okay, let's get rid of this. Notice, if I want to get rid of this AB, I can just multiply this by 2 so that this will have 2AB, this has minus 2AB, and then I can add the 2 together. So, see what's going to happen. If I multiply this by 2, this is going to become 2AB. This becomes 4A plus B. And if I multiply this by 2, what does it become? Negative 1/2. Ah. Now I can add this to this. If I add this to this, these two will cancel each other out. I'll be left with A plus B squared plus 4A plus B. If I add these two together, I'm going to get 0. We've come to the end of this battle. And at this point, what is common to these two terms? A plus B. So I have A plus B factored out. What is left is going to be A plus B plus 4 equals 0. So I found another set of solutions. A plus B is equal to 0, or A plus B plus 4 is equal to 0. Let's start with this one. A plus B equals 0 implies A equals minus B. Remember, I told you we can always find an answer. So if A is equal to minus B, we can go to some simplified version of this. Where is it? We can go here and actually use it. If A equals minus B, substituting in A squared plus B squared equals 1/2, I'm going to have A squared plus, remember B is minus A, or A is minus B, so B is minus A. If you square this, it's going to just be the same thing. It's going to be A squared equals 1/2. So what do I have? I have 2A squared equals 1/2. I have A squared will be 1 over 4, which means that A equals plus or minus 1/2. But remember, this is not our answer. This is still A. A is written in terms of something. We still need to go find what that is. Okay, so if A is plus or minus 1/2, then B, based on this condition, B, this implies that B is also equal to minus or plus 1/2, since one is the negative of the other, and that's what we have. So let's go find X and Y based on these two. Well, do we still have a solution here? Well, we're going to investigate whether this can be a solution or not. In order not to waste our time, this cannot be a solution. Okay? Because it will not fulfill this condition. Remember, what did we say A was? X minus 5 over X. Let's do it here. Minus 5 over 2, rather. Okay, so here we have A equals X minus 5 halves. And what did we say a was? Let's start with 1/2. If 1/2 equals x minus 5/2, then it means that x equals 1/2 plus 5/2, 6/2. So another set of solutions, I think we have to write out all the solutions. Okay, let's write them all out here. So x comma y will be equal to, the first ones we got were 2 comma 2. We also got 3 comma 3. And what else did we get? And when a is 1/2, b has to be negative 1/2. Don't forget. Okay, so when a is 1/2, we have to do the math also for b. So we have b will be equal to x minus 5/2. But b is now negative 1/2 because of the condition that when a is positive, b will be the negative version. So we have this is equal to x minus 5/2, which means that if you switch it, you have x equals negative 1/2 plus 5/2. Well, that's going to be 4/2, which is equal to 2. So that means when x equals 3, hey, y, come on, y, wrong assumption. This is y. Okay, this is y. So when x equals 3, y equals 2. Or if you switch it, when x equals 2, y equals 3. Those are sets of solutions also. When x equals 3, y equals 2. And when x equals 2, y equals 3. So here is a graph of these two functions and their intersections. As you can see, it's really weird. And there are just 4 sets of valid solutions. And we found all 4 of them. Never stop learning. Those who stop learning, stop living. Bye-bye.